So there's an interesting question of what is the implication of massive MIMO for small cell deployments. So in one sense, massive MIMO removes a lot of the pressing perceived need for small cells, because massive MIMO with its superior power control can give uniformly good service throughout the cell. So it's more or less eliminated, or will eliminate, the problem of what do you do on the people with low SINRs on the edge of the cell. So let's assume that is so. Then the question is there further useful work for small cells if you already have a network of massive MIMO base stations? We believe the answer is yes. We've been doing some research recently on contemporaneous, or you might say homogeneous, operation of small cells with massive MIMO. So the idea is you have deployed a massive MIMO cellular system, and now for certain areas of your cell you want to provide extra high throughput. You could do that with massive MIMO if you cranked up the number of antennas, but quite possibly a more economical thing would be to deploy one or more small cells in strategic locations. And the idea is these small cells would operate in exactly the same band of frequencies at the same time as does the massive MIMO system, and the terminals would be the same. In point of fact, the user wouldn't know whether he or she was getting this extra good service from the massive MIMO base station itself or from this small cell. And the principle of operation is the extra degrees of freedom that the massive MIMO array has permits it to serve its regular customers while steering a null or nulls in the direction of the users who will receive small cell service. So through this scheme, you avoid interfering between the two services.
What's the timeline on large-scale viability of massive MIMO? And I'm thinking of that in comparison to the timeline of 5G standardization.
That's a difficult question. I can't comment on the standardization. It can be a long process. For one thing, it depends on the deployment. You could have massive MIMO for certain dedicated applications where you now don't have a wireless solution, such as fixed wireless access to homes. On the other hand, if you want to do a complete replacement of 4G LTE, that's a very ambitious undertaking and would entail big standards changes.
What did you think of Mr. Song's from Huawei's comment that Moore's Law is dead?
I'm not an expert in electronics. It really must depend on the application. Massive MIMO, for example, some versions of it, the processing could be done by each antenna element itself. So in essence, you would be saying, I'll put an ASIC attached to each antenna to do all of the signal processing required. I won't have any central computing. There's no latency. There's no hassles with getting data up into the cloud. And I'm simply going to count on the fact that if I'm producing hundreds of millions of these ASICs, they will be very cheap. So indeed, even though they may not be smaller and smaller every year, the scale of production would bring the cost down, which I think is part of Moore's Law.